Again, because of time constraints, I have drawn out the entire problem ahead of time. So I want to go through with this breast calculation example, and this will be the final calculation example unless someone requests that I perform a specific one. With a breast setup, in this case right breast, most modern day radiation therapy departments, they're not going to, people are really going to limit doing wedges now. People have gotten away from doing wedges because we've learned that the medial wedge tends to scatter radiation to the contralateral breast and actually increases the risk of malignancy. And with the advent of segmented planning or forward planning using the MLCs to segment out the hot spot, wedges have kind of gone away, especially, and now with dynamic wedges as well. But for the example, I'm going to assume that I have an RPO and an LAO field for my right breast. It's going to be a half beam block technique where the isocenter is going to be, about a centimeter in the lung. I'm going to be prescribing 180 centigrade to my calculation point. That's going to be about 3 centimeters out from isocenter on the same plane as isocenter. I have the sternum here, my right lung here. My patient separation is 25 centimeters from where my RPO intersects the patient body to my LAO intersects the patient body. Note that my depth of calculation is not going to be 25 divided by 2. It's going to be the depth of the calc point, which is going to be on the thinner portion of tissue, so my depth is actually going to be less than 12.5. I have 30-degree wedges, and I'm going to assume equal weighting because I don't want to do 2 calculations. I don't have the time. So this is going to be strictly for the RPO, but it's basically the LAO. Just the opposite side. The other thing with breasts is we're going to have at least 2 centimeters of flash to account for, patient setup, breast swelling, breathing, etc. Down here is the port. I accidentally drew this too big. The half beam block, so my isocenter is here. This portion is going to be my block portion, blocking out a portion of the lung. And then I have my patient contour here coming down, and my calc point is going to be located here 3 centimeters out from isocenter. Here I have 2 centimeters of flash. So my prescription is going to be 180 centigrade times 28 fractions to 50/40. I'm prescribing at the 95% isodose line to the calc point, not isocenter. My monitor unit equation is as follows. I'm going to have collimator scatter, the phantom scatter, my TMR, my isodose line, which now is going to be 0.95 instead of 1.0. Inverse square factor again because my calibration conditions are at 100 centimeter SSD, whereas my calculation point is roughly going to be at 100 centimeter SAD. I have a wedge factor since I have my 30-degree wedges, and then I also have an off-axis ratio or off-axis factor because my calculation point is off-axis from the isocenter. So MU RPO equals MU LAO. I have 90 centigrade from each beam for a total of 180 centigrade. My equivalent square field sizes from the RPO equals the LAO, but I'm going to say my collimator equivalent square is 15, and I'm going to say my blocked equivalent square is 12. Okay. The other condition that I'm going to give you is my depth of calculation point. My depth to the calc point is going to be 10 centimeters. So again, that's not here to here, that's here to here is 10 centimeters. Okay. My off-axis is 3 centimeters. Now, plug and chug, look these up in the data tables that I gave you, and you get S sub C is 1.017, S sub P is 1.006, my TMR is 0.783, 0.95 comes from my normalization percentage given by the physician. I have source to calibration distance divided by source to calculation distance. Now, this is assuming that my calc point is directly on the same level, left to right, as my isocenter. My calc point cannot be any more this way, and it cannot be any more this way, otherwise this bottom number changes. Okay, and I have an inverse square law component. What I'm assuming is that my calc point and iso are in the exact same midplane, just like this. Okay. Now some might argue, well, yeah, well, technically you're off axis, and if we draw a triangle from the source to that calc point, let me illustrate it here. This is source ISO, and this is calc point. This distance is going to be larger than this distance, so that's going to affect this. Well, I'm assuming that because I'm only 3 centimeters off, that this is negligible. In fact, I would encourage you to look that up. If I'm 3 centimeters this way and I'm 100 centimeters this way, what is this distance? And how does that change my inverse square factor percentage? 0.553 is going to be my wedge factor. Again, the wedge factor is a transmission factor only. It only affects the amount of the intensity of the radiation that gets absorbed by the modulating device, by the wedge. Okay, so I looked this up for 6x and my field size is 0.553. The next thing I have to do is I have to look up an off-axis factor, okay, or off-axis ratio. And the off-axis ratio depends on energy, distance off-axis, depth, and it also is going to vary on the type of wedge that I have. So if you look in the data tables, I need a 30 degree, and we have them listed at 30 degree thin, 30 degree thick, and 30 degree non-wedged. Means, are you off-axis in the thin, the toe portion of the wedge? Are you off-axis in the thick portion of the wedge? Or are you, are you off-axis in the non-wedged portion? So, if I have a 30 degree wedge, this is central axis. If my calc point is this way, you use the 30 degree thick. If my calc point is this way, you use the 30 degree thin. And then if I turned the wedge up and looked at it, and I looked at the wedge like this on end, and if this is ISO, and if my calc point is anywhere along the longitudinal direction of the wedge, try and draw this like three-dimensionally, then I use the non-wedged off-axis factor. Okay, so I look that up, and I'm at 0.94 for 3 centimeters off-axis for a 30 degree wedge in the thick direction. Okay, you plug and chug these numbers and you get 221 MU. Why do we need wedges for breast? Well, I have this distance from here to here is 25 centimeters. Well, what's this distance from here to here? You know, let's just say for the sake of argument that this is 12 centimeters. Well, if I deliver 221 monitor units with no wedge, if I prescribe to my calc point, which is at a 10 centimeter depth here I'm only at a 6 centimeter depth, and I want to pump in monitor units to deliver 180 centigrade here, well, here I have less attenuation, so I'm going to have hotter dose. So I need to put a wedge in, some sort of a beam modifying device that diminishes the dose up here and lets more through down here. So I throw a wedge in. So what happens is I mitigate the hot spots up here and I push the dose deeper. Okay? Most departments now we do this through field segmenting.